Question 9 is coming from APs and GPs. The first part is from the GPs. The first term of the progression is cos theta, where theta ranges from 0 to pi over 2. Part A, for the case where the progression is geometric, the sum to infinity is 1 over cosine of theta. And then Roman 1, show that the second term is cos theta sine squared theta. Now this is APs, GPs, but then coupled with trigonometry. Now, first of all, we have been given A being equal to cosine of theta. We know that sum to infinity of a geometric progression is A out of 1 minus R. So this one is equal to 1 over the cosine of theta. Okay, now we are having our A as the cosine of theta, then out of 1 minus R, which is equal to 1 over the cosine of theta. So I'll cross multiply, and then we get cos squared theta, which is equal to 1 minus R. So when I bring this one this side, it simply implies I want to get R, okay? So R will be equivalent to 1 minus, cos squared theta. And this is the same as sine squared what? Sine squared theta. Now the second term of a GP is A R. So our A is the cosine of theta, and then R, we have gotten it as sine squared theta. So we shall just put this one here, as simple as that. Then Roman 2, find the sum of the first 12 terms when theta is equal to pi over 3, giving you answer correct to 4 significant figures. So we need to first find the first term. Remember, it is cosine of theta. So we put this pi over 3. Cosine of 60 is a half, so this will be a half. And then R is sine squared of theta. So I will have sine of pi over 3. Then after that, I square it. Now this is root 3 over 2. When I square it, it is going to give me 3 over 4. Now, the sum of the first n terms of a GP, since R here is 3 over 4 is less than 1, then I will use A into 1 minus R to the power of n out of 1 minus R, because it can also be A into R power n minus 1. We use this one when R is greater than 1. But if it is less than 1, then we use this one. But you can use any, okay, because if a negative comes out, then it cancels. So whichever you want. Now, the sum of the first 12 terms is going to be our A is a half. And then we have here 1 minus, this is 3 over 4. Then we shall power this one with a 12. And then out of 1 minus 3 over 4. You just put this one in the calculator and then you get the answer. 0.5 into 1 minus 3 over 4 is the same as 0.75. Then power 12. Then close that bracket. Then we go down. This one is going to be 1 minus 0.75. So this is 1.9366. Then 47296. So to 3 significant figures, this one is actually going to be 1.937. As simple as that. Part B, for the case where the progression is arithmetic, the first 2 terms are again cos theta and this one here, respectively. Find the 85th term where theta is equal to pi over 3. So we need to get our first and second term. So they are given here, but then we need to get the common difference. Okay. So A is again cosine of pi over 3. Okay, which is a half. Then the second term is A plus D, which is equal to the cosine of theta sine squared theta. So the common difference is going to be cos of pi over 3 and then sine of pi over 3. Then I square this one here. Then I'll subtract a, which a is a half. So what do we have here? We have a half, then times, this is root 3 over 2. So root 3 over 2, when we square it, we saw it as 3 over 4, right? So times 3 over 4, then minus a half. So what does this one give us? This is 3 over 8 minus a half. And of course, I'll multiply this one by 4 and then this one by 4 to get the equivalent fraction. So 3 minus 4, that is a negative 1. So we shall get negative 1 over 8. So this one will be negative 1 over 8. That is our D here. Now, the 85th term shall be equal to A, then plus 84 of D. Remember, the nth term of an AP is A plus n minus 1 D. Okay? So our A, remember, is a half, then plus 84, then times the D, which is negative 1 over 8. So altogether, this one is going to give us what? 0.5 plus 84 into negative 1 over 8. So this one gives us negative 10. So our answer here is negative 10.